Today we're reviewing, or for some of you maybe learning, some algebra vocabulary. So the first term or word that we're going to learn about is the word variable. And variable in math is just a letter that represents an unknown value or a value that can change or vary. And in our last unit, we were working with lots of variables. For example, we talked a lot about the cost for something. So we used the capital letter C for cost. So that was a variable. And it might have been the capital letter C cost for N items. So N could be a variable. Or for D kilometers driven. Or T hours. So all of these letters we were using for variables. In math, we often will use an X as a variable or a Y as a variable. So these are things that we will be frequently using over our next unit. When we're talking terms, a term is just a combination of letters and or numbers that are connected by multiplying or dividing. Now it could just be letters, it could just be numbers, or it could be a combination, as I said, by multiplying or dividing those. So for example, the number 6, that's a number, that's the number 6. That's an odd looking number 6, it almost looked like the letter B. There's the number 6. That is a constant term. It is a term. There are no variables with it, and there's nothing being multiplied or divided with it other than I could put a 1 beside it. Likewise, a negative number is a term. It's a constant term again. I could just have a letter. I could have the letter X. That is a term. And then I could start putting these together like 3 times X. That is a term. They're connected through multiplication. And in math, we don't normally put the times sign anymore when we're working with algebra because the times sign looks like the letter X. Just remember that when you have a number beside a variable, multiplication is implied. Sometimes you'll even see a dot, not at the bottom like a decimal, but in between the two things, and that implies multiplication. But we usually just leave it out and have 3 and then X. We could also have something like this, where we have a 2 and an X and a Y. That means 2 times the value of X times the value of Y. So all those things are being multiplied together. So it's more than just 2 sometimes. We could have 3 times X divided by Y. That is connected through both multiplication, 3 times X, and then the division with the Y on the bottom. We could have X divided by 5. That also is a term. So notice there was no adding or subtracting in those. If we start adding and subtracting, then we have multiple terms, not just one term. All right, another thing we need to know is the word coefficient. A coefficient is the number that's multiplying the variable in a term. So in this first example, the 5 is the coefficient. So our coefficient here is 5. So our coefficient is 5. And in our next example, where we have a minus 4x squared, the coefficient is negative 4. Now the next example is a little tricky. There is no number in front of the x. There's just a negative sign. When there is no number in front, that number is assumed to be a 1. So this actually has a coefficient of negative 1. The next one, if I look at the number parts, we have a 2 divided by 3 as our number parts, so the coefficient is 2/3. In the last one, I'm just going to check and make sure you were listening. Predict what you think the coefficient is. That's right. If you were paying attention back here, there was no coefficient written, so it's assumed to be a 1. So this has a coefficient of 1. All right, constant term. Now, I did mention this up above when we talked about terms. A constant term is a term that contains no variables. Its value does not change. It's just the value we have. So, for example, the number 5 is a constant. It's just the value of 5, no variable to it. Negative 3, that's a constant. It has a value of negative 3, nothing else. 0, 0 is a constant. It's the value of 0. You can also have fractions like 1/3. That is a constant value. It does not change. And another constant we had earlier this semester that people sometimes confuse for a variable is pi. Pi is a symbol, but that symbol represents a constant value of 3.14 approximately. Okay, polynomials. Polynomials are just expressions that are made up of terms, and the terms are separated by addition and subtraction. So in the second definition we had up at the top, we didn't have any adding and subtracting, so these were all single terms. I separated them out with the commas, but now down here I have terms that are connected through adding. So 3x plus 5, that is two terms. And when we have two terms, we call that special polynomial a binomial. So two terms together makes a binomial, and the prefix bi, if you think of the prefix bi, a bicycle has two wheels. So that's a way that can help you remember that binomial means two terms. If we have this case here, and my arrow kind of got shifted, but that is a case where we only have one term. We don't have any adding or subtracting to it. So there's one term, and a one-term polynomial is specifically called a monomial. So mono means one, and so one term is called a monomial. And my last example here has a 2x, and then we have a minus y, and we have a plus 8. So we have three terms here, and I bet you can guess what three terms are called. Bi is 2. We know tri, like triceratops or tricycle, means 3. Trinomial. So these, if you have specifically just one term or two terms or three terms, we do have these special names, but just in general, we call them polynomials. Moving on to the next slide here. And I'm missing part of my, here we go. There we go. I got a little bit, that's a bit better there. Okay, so more than three terms is just referred to as a polynomial. So we don't have a special name for 4 terms or 5 terms. We just call them polynomials. And we use the word polynomial when we don't need to be specific about the number of terms. So if we're talking about things and some have 2 terms and some are 3 and some are only 1 and some are 4, we just call them polynomials in general. The other thing we need to know is polynomials are usually written in descending order, descending powers. These terms are written so that the exponents on the variables are in order from biggest to smallest, greatest to least. So this example we have here, I have an 8x. The x has an exponent of 1. So when the exponent's not written, it's assumed to be 1. There. We have a 3, which has no exponent on, we have no x's at all on that one. And then we've got an x squared. So my biggest exponent is the x squared. So if I write this in descending powers, this should actually be equal to 4x squared. And then we're going to have the plus 8x. And the plus comes from the fact that there's no sign written in front of the 8, so we know it's a positive. And then we have the take away 3. So when I'm writing things down, the sign in front of the term always travels with it. So I had a positive 4x squared. I don't normally write the plus in, but there is an assumed plus there. All right, the second example, I want you to try that. Look at the biggest power, the biggest exponent on the y, then the next biggest, all the way down to the constant term. Your constant term should go last if you have one. So try it, see what you get. Okay, I should have 9y to the 5 minus 7y to the 4. I hope you put this video on pause to try it. Plus 0.5y squared, because the sign in front of the 0.5, there is no sign written, so it's assumed to be positive. We have a plus 3y, and then we have minus 9. The constant term is the last one. All right, the last part of this note, we want to look at like terms. Like terms are terms that have the same variables with the same exponents. So for example, if I have 2 x's, the exponent is just a 1. I have a minus 8x, again, exponent is 1. I have just an x, exponent is 1. I have a 2/3 x, exponent is 1, and a minus x, exponent is 1. So these all have x's with exponents of 1, so these are like terms. These can actually be combined. I could add 2 x's with minus 8 x's, put them together, and I would actually get minus 6x if I were just adding these first two together. You're really just adding your coefficients to get there. There is another video for today that you'll explore that further. The second example here, these are all constants. There are no variables to it, so those are all like terms. They could all be combined or put together to be one single term. The next one, we have a y squared 6 of them in fact. We've got negative 9y squared. We have a half of a y squared. The variable parts are all the same, so those are like terms. Now the next one, we have a 5xy, so the variable part is xy, a minus 2xy, variable part is xy, and then a 3yx. Oh, wait a second. Is yx the same as xy? Well, let's think about that. If I have 3yx, and let's say y was equal to 5, and x is equal to 4. That would mean I would have 3 times y, which is 5, times x, which is 4. 3 times 5 is 15, and then 4 groups of 15 would equal 60. Well, let's check that. If we had 3xy instead, if we turn that around, I would have 3 times 4 times 5, which is 3 times 4 is 12. 12 times 5 is also 60. In fact, the order in which you multiply things together, it doesn't matter. 2 times 5 is the same as 5 times 2. 9 times 7 is the same as 7 times 9. So these are also like terms because that yx is the same as xy. All right, last two examples here. The first one is 2 times x times y. The second one is 3y. The second one is missing the x part, so the variables are not exactly the same. These are not like terms. Take a look at the last one. I have 4x, which is just 4 times x, and then we have 2x to the exponent 2. 4x only had an exponent of 1. This really means for the second one, we've got 2 times x squared, or 2 times x times x. Because the exponent pieces are not the same, these are not like terms. They cannot be added together or combined. Okay, time for you to continue on with the next activity that I have for you, which is on the back of this handout, where you're going to complete a crossword that goes through some of this vocabulary for today. You may wish to go on with the next part of the lesson instead, and save that for afterwards when everybody could be working on the same thing at the same time.